Hi everyone! In this video, we're going to talk about how to describe piecewise functions. Now, a piecewise function is what you see here, and this might look a little bit different than some of the functions that we've seen before. My primary reason for saying that is because we've got something kind of funky going on over here where we can actually see that our graph has been split up into different parts. So I'm going to start off with the definition of a piecewise function. I highly recommend that you jot this down somewhere so that way you have it to refer back to. A piecewise function is a function that is defined by different formulas, and that's what you're seeing here. In this section, you're seeing the different formulas. So it's defined by different formulas along different parts of its domain. Okay, so again, I'm just going to read the definition out one more time. A piecewise function is a function that is defined by different formulas along different parts of its domain. So I did just mention that the different formulas part is what you're seeing here. And then the different parts of its domain, again, remember that this is like a throwback to something we spoke about a while ago, which is like, what are all of the x values? And that's shown in this second part of how this piecewise function is written out. So you'll be asked to describe how this function is behaving on different parts of its domain. And again, this section, when it says different parts of its domain, we're talking about for different x values. And the nice thing about that is that you are already given those parameters here when you look at a piecewise function. So we can start this off in two ways. I'm going to first just take a look at this part of the graph here. This part of the graph I know is the x squared portion. And one thing that I need to remember here are the different types of functions that we've seen. I know that this looks like a portion of the parabola, but this is also a quadratic function. And I'm going to just jot that down here. This is partially a quadratic function. And then if I take a look at the second part of our piecewise function, this 2x plus 1, I know that's shown over here. And that one I can tell is just a linear function. So it's just going along a straight line. So I want to make sure that I'm using those two terms as I describe my graph. And I also want to make sure that I'm being very specific about what's happening in the domain when those two parts of the graph are existing. So when I take a look at this, we identified this as being a quadratic function. So I'm going to start off by first saying that this graph behaves like a quadratic function. And I want to make sure that I'm explaining for all what x values is it behaving like a quadratic function. So here I'm going to say it behaves like a quadratic function for all x values. I'm going to come back up to here where I saw my x squared. For all x values less than or equal to 1. So again, this is one way that I'm going to explain it behaves like a quadratic function for all x values less than or equal to 1. And if I was just to read straight from the different formulas here, you can say that f of x is x squared for all values of x that are less than or equal to 1. And then what I'm writing out just shows you another way that you can talk about the behavior. But now I've only spoken about the first half of our piecewise function, so I want to make sure that I'm tackling the second half for the second part of this domain. And now I'm going to use that same format to say that this function behaves like a linear function And again, come back here to the domain, and we're going to notice that we also have, even if you weren't given it, you can tell that it's just a greater than because of the open circle here. So it behaves like a linear function for all x values greater than 1. So this is what we want you to start practicing today, is just being able to talk about what's happening to these piecewise functions at different parts of their domain. So I would recommend that you start off by taking a look at the graph itself, identify is part of this quadratic, is part of this linear, and then come back over. And again, like notice here that in my quadratic I had my exponent, and then you're going to break down describing that function into the different pieces of your graph and like of the domain. So if we had a third point here, you would have a third statement about how the function is behaving.